Hello, ladies and gentlemen. Today's video is going to look a little different because I'm in Word and I'll be drawing with you. So this is the front of your foldable for area of triangles, parallelograms, rectangles, and trapezoids. And we're even going to talk a little more about perimeter too within these problems. And all this stuff should be review for you. So you should have this foldable, a pen or a pencil, and of course your notebooks. And if you really want to, you should grab a calculator too. So we're going to zoom into this first portion of the foldable. All the area formulas. So the areas of rectangles and parallelograms. As you guys probably remember, area is the stuff that just makes up inside of the shape, okay? So formulas. Area is equal to the base times the height. In a rectangle, it doesn't really matter which side's the base or the height. But within a parallelogram, when we talk about height, we want the perpendicular height, or the height from this to this. We do not want that slanted height. So if they give you this slanted height, say that it's 5 and they tell you that this is 2, then you're going to have to find that height, okay? So that's something that we'll be doing today. So remember that this is the actual height where this is the base. And same thing goes with triangles and trapezoids. We want the perpendicular height when we look at those equations. So area is equal to base times height divided by 2, or some people prefer 1/2 times base times height. Either way it works. All we need to remember is that when we're looking for height, we definitely need to have the perpendicular height. And so I'm going to scroll down here to the trapezoids. So just like I said, perpendicular height, and then the formula base 1 plus base 2, it doesn't matter which one's called which. We can call the top base 1 and the bottom base 2, or vice versa. It doesn't matter. And we'll be going through some example problems. So let's start with example number 1. Okay. So example number 1, it says find the area and the perimeter. So I'm going to zoom in a little more. Oh, sorry. I'll scroll over and down and stuff. Okay, so we have a parallelogram shape, and we know that this distance, if I count it out, is 1, 2, 3, 4, 5, 6. So it's a distance of 6, which means the opposite side is also going to be a distance of 6. And we want to find that perpendicular height. So this height right here, which is 1, 2, 3, 4. 4. So when we find the area, we're just taking that 6 times 4, or that base times height. So area is 24, and they didn't give me a label, so it's just units squared. Okay, now we need to find this side length and this side length in order to find the perimeter, because remember, perimeter is just when we add up all the sides. When you add all sides is perimeter. All the sides added together. Think about like a fence around a yard or something, okay? So that distance of all the sides added together. So we're going to have to actually use, and I'll grab a highlighter here, the Pythagorean theorem and break this down into a tiny, 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 tiny right triangle, okay? So if we just look at that yellow triangle, we have a distance of 1 right here, and we still have a height of 4. Remember, Pythagorean theorem is a squared plus b squared equal to c squared, where c is the hypotenuse, or in this case, it would be this side or this side. So my a and b don't matter. They just have to be legs of the right triangle. So it would be 1 squared plus 4 squared is equal to c squared. 1 squared is 1, plus 4 squared is 16 is equal to c squared. 1 plus 16 is 17 equal to c squared. I still have to get this alone, so I'm going to have to undo that square by taking the square root. So that side is the square root of 17. So I don't want you guys for area and perimeter to do any decimals. I want you to leave it in this form with radicals, okay? So the perimeter then is going to be, here I'll circle it in a different color, 6 plus this 7 square root of 17 plus the square root of 17. Okay, so 6 plus 6 is 12, plus we have 2 square roots of 17, because this guy is the square root of 17 and that guy's the square root of 17. So we have plus 2 square roots of 17. And if you guys don't know how to add or combine like terms with square roots, star this part in your notes, and then when you come back to it in class, you can ask me how that works. Or if you get stuck with radicals and breaking them down and stuff like that, just star it in your notes. And that goes for anything. Just always star the stuff in your notes if you want me to go through it with you later in class, okay? Okay, moving on to example number 2. So the area of a parallelogram is 112 square meters. What is the value of x? Okay, so we have to start off with area is equal to base times height. They told me area is 112, so I'm replacing a with 112. We know that the base is 11 plus 5, so that's going to be 16, and they told me that height is going to represent x. So if I divide both sides by 16 to get x alone, that's how I solve. So 112 divided by 16 should be 7 meters. So that was example number 2. Pretty easy, right? Okay, now moving down to example number 3. Area and perimeter of a triangle. So remember, we want that perpendicular height here, which is a distance of 1, 2, 3, 4, 5. And then my base is a distance of 3 and 1. I'm going to break it up like that for a total base of 4. Okay, so A is equal to 1/2 times base times height. Well, my 1/2 times my base is 4 times my height is 5. 1/2 times 4 is 2 times 5 should get me 10 units squared. Okay, so for perimeter, we have to find this side using Pythagorean theorem and breaking it up into this right triangle, this yellow one, okay? And then we also have to use Pythagorean theorem for this tiny triangle to find this side, okay? So we're going to have to use Pythagorean theorem twice. And remember, Pythagorean theorem is a squared plus b squared is equal to c squared, where c squared is the hypotenuse. So I'm going to just draw a line so I can show some work. So I'm going to do this guy first. So 3 squared plus 5 squared is going to be equal to, let's call this side c squared. 3 squared is 9, plus 5 is 25, or plus 5 squared is 25. It's equal to c squared. 9 plus 25 is 34, equal to c squared. And we have to get rid of that square, so we're going to have to square root. So this side is going to be the square root of 34. Before I wrote this down, you should always ask yourself if you can break this guy down. And 34 cannot be broken down. And again, if you need help with breaking down roots on this, if you don't remember how, star it and then we can come back to it later in class, okay? Okay, now moving on to this side that we'll call C. So we have a little side length of 1 here and a height of 5, so it's going to be 1 squared plus 5 squared is equal to c squared. 1 squared is 1, plus 5 squared is 25, equal to c squared. 1 plus 25 is 26, equal to c squared. And then we're going to have to square root to get that alone. So that's 26 is equal to c. So on this side, it's going to be the square root of 26. So ask yourselves, what are factors of 26? 2 and 13. 2 is not a perfect square. 13 is not a perfect square. Okay, I guess we can't really break that down, so that's as good as that's going to get. So that means that my perimeter is going to be kind of ugly because I'm not using decimals. I'm using exact form. So it's going to be 4. Here, I'll show you in a highlighter pen. I'll circle it in green. It's going to be 4 plus the square root of 26 plus the square root of 34. We cannot combine the square root of 26 and the square root of 34 because they are not like radicals. Like on example number 2 over here, example number 1, we had the square root of 17 and the square root of 17 to make 2 square roots of 17. Well, back up over here on number 3, the square root of 34 and the square root of 26 aren't the same because they don't have the same number under the radical, so that can't work, okay? Okay, moving on to the last one, and I'll zoom in so we have a little room. Oh, sorry about that. We'll zoom in so I have a little more room. Scroll down to example number 4, okay? All right, find the area and the perimeter. So if you get to a trapezoid and you're like, oh crap, like on a learning check, and you're like, I do not remember the formula, break it up into stuff that you know. You can drop a perpendicular right here, and you know that this is going to be a rectangle of 15 and another side length of 9, and you know that this triangle is going to have a base of 11 because 20 minus 9 is 11. Okay, so if you don't remember the formula, that's okay, but I'll show you how to use the formula in case you want to use the shortcut. So area is equal to the base 1 plus base number 2, all divided by 2, and that whole thing times the height. Okay, so in this case, our bases are 9 and 20, so those two added together is 29 divided by 2, all times the height, which is 15. So if you